our third and final startup in the product section is Soliyarn, another Greentown member, whose patent-pending vapor deposition process converts off-the-shelf textiles into electrically conductive fabrics. Please welcome Trisha Andrew, founder and CSO. I will pull up your slides now and take it away.
Good afternoon, everyone. My name is Trisha Andrew. I'm a professor of chemistry and chemical engineering at the University of Massachusetts Amherst, also the founder and CSO of Soliyarn, which is a company that we started in order to commercialize a lot of the work that my lab has produced over the past decade in electronic textiles and generally functionalizable coatings for textiles. Next slide, please. So our company is really focused on bridging the areas of microelectronics fabrication to the very comparatively unsophisticated manufacturing routines that are used in textile manufacturing around the world. And we use a patent process called chemical vapor deposition that we developed specifically to make polymers as coatings on textiles in order to put these coatings down on any kind of commercial off-the-shelf fabric or pre-made garment or thread or yarn. And this schematic shows you some of the technologies that we've been able to actually develop and prototype both in my lab and at the company scale at slightly different manufacturing readiness levels. We could span the spectrum of different kinds of devices from health monitors all the way to energy harvesters that are grown directly on your clothing, on your garments, or on the fiber level, and also knit, sew, or yarn together a garment after coating these fibers. And in particular, something that we've started investigating a lot more in the company is how to make functional coatings that get rid of some of the more pernicious chemicals that are used to make coatings, specifically for waterproofing. Next slide, please. So some of the customer pains when we talk not only about electronic textiles, but also waterproof anything, is the idea that people really want to have comfortable clothes that they could control the aesthetics of and really control the feel of before they think about any other higher level function. And that's where our company really comes in. That's where our expertise and our uniqueness is. Our vapor phase coating process actually is agnostic to whatever it's coating. Whatever goes into our reactor gets coated with the polymer that we put down that we select based on the monomers that we flow in. What that also allows us in terms of manufacturing is that we are completely solvent free. So we do not generate any wastewater runoff through any of our processes, whether we're making conductive garments or if we're simply putting down a waterproof coating. And this is really important because on the left of the slide, you actually see some images from the Associated Press and various foreign press associations that are taking pictures of rivers that are downstream from textile manufacturing facilities, largely China, Brazil, and India, that are showing you what the water runoff looks like from those factories. And textile manufacturing is actually the third largest polluter of human industry right now. And we don't pollute air, but we actually produce fresh water. And this is a very precious resource that is much harder to purify and there's many fewer efforts out there to de-chemicalize water, for lack of a better word, not just desalinate it, but get rid of these surfactants and dyes and other waste products that result from even simply coating textiles. And so next slide, please. What we do, this is a very small cartoon, a representative cartoon of one of our larger chambers that is right behind me, actually, in our lab in Charlestown. And this gives you an idea of the process that we enact in order to coat, again, garments, off-the-shelf textiles, and fibers and yarns. We actually perform a polymerization inside these reactors. This reaction is an organic reaction, which means it goes very, very quickly. On the order of seconds to microseconds. And the other thing is the materials that we produce are soft, which means that they don't actually have to be grown very slowly because they don't have any crystalline nature that is required to basically enact their function. And so we could pump fibers and fabrics and garments through our reactor very, very quickly and create micron size coatings on these materials, on these garments, that have a function that we choose based on a monomer. We have a team of 5 materials chemists and mechanical engineer that basically chooses the monomer that we use in order to address the function that we actually end up generating. And again, because we introduced our monomers from the vapor phase, there is no solvent involved in any of these processes. And also in terms of the process itself, we get grafting down onto the surface of the garment. And so these coatings that we develop, whether they're conductive or just waterproof, happen to be chemically grafted. And so you can wash these coatings. We've done up to about 150 washes in industrial cycle washing machines and home cycles. And these coatings just don't come off, and you can't rub them off. And so they withstand everyday wash and wear. And lastly, I think we could go to the next slide. We've basically looked at developing chemistries to get this kind of waterproofing accomplished with something that is called a PFC-free material. Other than the water pollution and runoff, the biggest problem facing textile manufacturers currently is that all of the chemicals that are used to waterproof outerwear, or even some of the more expensive luxury garments, has a lot of fluorine. They're greater than 60% fluorinated chemicals, and it's those chemicals that result in the waterproofing ability. And that is especially bad for the ozone layer of our Earth. Highly fluorinated chemicals deplete the ozone layer, just like CFCs do. And so all of these coatings that are made on the garments that you interact with every day are actively leading to not only water pollution, but also ozone depletion. And these are some gifts that you see that our company had taken from our newly developed PFC-free coating. You get the same function of water repellency, both in static and dynamic context. In other words, if you are sitting in a bath of water or out on a boat undergoing whipping winds with water kind of being shoved at you. And you get the same kind of waterproofing that is currently known for fluorinated chemicals, but with our completely fluorine-free monomers and starting materials. I think that is the end of our presentation. And so in summary, we basically can retain the feel, form, and comfort of your garment. We basically could start with whatever you want and enact our solvent-free process in order to waterproof or make your garments into electronic devices if that's what you want, without the use of solvents, without generating wastewater runoff, and also using chemicals that are fluorine-free for next generation coatings. Thank you.
Hi, Trisha. Thank you so much. Once again, the alignment definitely came through in your presentation. Thank you for it.